Hi there, in this video I'm going to show you how to prove or how to show if a root lies in a given interval. Okay, so if we're given an interval, I'm going to show you whether a root exists in that interval. Okay, so that method is called what we call that the change of sign rule. Okay, so change of sign rule. Okay, so that's what it's called. So let me underline that. Okay, so let me explain the change of sign rule. So if we're given fx equals 0, okay, so if we're given the equation fx equals 0, and if f of x is continuous. So continuous meaning there's no breaks in the function. Okay, so this rule is only applied if your function is continuous, so no breaks in the function. So given f of x equals 0, and if f of x is continuous, okay, also given an interval, so a to b. Okay, so if I have two values given, so here's my interval, a and b included, so that is the same as writing x lying between a and b inclusive. Okay, so these two are exactly the same. Okay, now if you calculate f of a, and if that value is less than 0, and if you work out f of b, and if that value is greater than 0, okay, or vice versa, so all the other way around, so if f of a is greater than 0, or if f of b is less than 0, in other words, so if there's a change of sign, so that's what we call, why we call this the change of sign rule, okay, then there exists a root in the interval AB. So if you have a change of sign, that proves that a root lies in the interval AB. Okay, so that's the change of sign rule. Now you need to be careful when using a change of sign rule. Okay, and let me explain why. Okay, so remember the term root. A root is a point of intersection of your curve or of your function with the x-axis, or it's a solution to the equation fx equals 0. Okay, now supposing we have the sketch of, let's say, y is equal to x squared. Okay, so if you draw x squared, we all know it's a quadratic of this type. Okay, and it has a solution when x is 0, y is 0. Okay, so it has a solution where x equals 0. Now if we go back to this change of sign rule, we're saying that if f of a is less than 0, and if f of b is greater than 0, or vice versa, then a root exists within the interval. Okay, now if I take this interval, so if I have this x value of -1 and this x value of +1, okay, so if I calculate f of -1, I'm going to have a value up here, okay, so a positive value, and if I calculate f of 1, I'm going to have this a positive value also. Okay, so if I'm calculating f of -1 and f of 1, for example, okay, we're going to have positive values. Okay, however, if we go back to our change of sign rule, it says that we only have a root if there's a sign change. So here is one exception. We have a root, as you can see, for y equals x squared when x equals 0. However, this disproves this, because if you calculate f of minus 1, you have a positive value. If you calculate f of 1, you have a positive value as well. So this is one of the exceptions to the change of sign rule. So you need to think about this before going with the change of sign rule. Okay. However, when you do the examples, okay, so when you do examples, so for example, exam questions or textbook questions, all of the questions in there will probably have questions. So if they're change of sign rule questions, your functions A would be continuous, I would assume, and there would be a change of sign taking place. Okay. However, I've given you an exception to the change of sign rule here. Okay, so you need to tread carefully when applying that rule. Okay, so that completes this video on the change of sign rule. In the next video, I'll go through some examples showing you how this change of sign rule works.